Uh, First and foremost, thank you, everyone. Good afternoon, good morning, good evening, wherever you're joining us. Thank you for joining us at today's live stream. My name is Nikola Đurđić. I am a recruitment officer at the Faculty of Applied Science and Engineering here at the University of Toronto. Today, I have with me Professor Scott Ramsey and Joby Cho, a just graduated materials engineering student, from my understanding. I'll let both of our panelists introduce themselves in just a few moments. But before we get into that, I do just have some housekeeping information that I want everyone to be aware of. So first and foremost, today's live stream really is about materials engineering, the program, the opportunities available to you, and really what it all entails. Please bear in mind that we will not be taking admission-based questions on screen for this presentation. Nevertheless, my colleague Tyler, who will be handling the Q&A feature and the chat feature, we'll be more than happy to answer any questions or get you in contact with anyone that might be able to help you based on those admissions related questions. Moreover, if you do have any specific materials engineering questions, we do have the Q&A feature where you can input your questions, and we can, if we do have some time, we'll get to those questions in our presentation as well. We have some pre-selected questions already, but of course, if we do have some time, we'll be more than happy to answer any participant or attendee questions as well. So without further ado, I'm going to ask first Professor Scott Ramsey to introduce himself, and then Joby, if you're okay, please feel free to introduce yourself as well.
Sure. Okay. Yeah. Hi. It's good to see everyone. I mean, when I say see everyone, I just see their names, but it's good to see a good number of people here. Yeah. So I'm Scott Ramsey. I teach material science, obviously. I teach a really big first year introductory chemistry and material science course, and then I teach a few other courses in upper years. Yeah, I love it. I mean, I'm biased, of course, but I love the content. And so anyway, I'm happy to answer any question you might have. I guess I could talk for ages about many things, but I'll leave it there for now. And if you have some other questions, happy to answer them.
Wonderful. And Joby, if you don't mind introducing yourself, that'd be great as well.
Sure. Hi, I'm Joby Chua. I am, just recently graduated from MSc, so I'm a MSc 1T9 plus PAY. And now I'm in my first year of my MASc, so Masters of Applied Science at the same department, so materials engineering. So I research electrochemical supercapacitors. So yeah, if you have any questions about the undergrad or even the graduate program, happy to answer.
Wonderful. We got a really experienced crew today with us, which is awesome to see. First and foremost, the first question I want to pose to both of you is really, what is materials engineering? What does it entail? And I guess really, what does it mean to you as well? Professor Ramsey, if you don't mind starting, that would be wonderful.
Yeah, sure. Actually, one thing I forgot in my intro I wanted to mention, I always feel these days I have to just explain that I've got this mustache for Movember. I don't normally have a mustache. So if you think I look really creepy, normally I'm clean shaven. Anyway, although highlight of like my week, Chris Hadfield liked the tweet that I put up because I'm trying to go for the Chris Hadfield mustache. So that was amazing for me. Anyway, he's like a hero of mine. Anyway, MSc. Yeah, what's MSc about? I love it because, everybody I think has a lot of knowledge about how materials behave, right? If I have this plastic cup here and I drop it, it'll probably bounce, right? It won't shatter. But if that was a ceramic cup and I dropped it on a concrete floor, it would shatter. There's things like that and what material science is about is understanding based on sort of the atomic scale why things behave the way they do. And once we understand that, we can change features at this sort of atomic scale and around that and change the properties. So, we always talk about this sort of microstructure property performance relationship. And really that's a lot of what material science is about, and understanding why materials behave the way they do, and then being able to, as engineers, select the right material, but also change materials and come up with new materials, new properties to do better things for the world.
Wonderful. Thank you so much. And Joby, if you don't mind, you can add to that whatever you think, materials engineering and material science really means to you as well.
Yeah, I guess as an undergrad, you could say it sort of exists at the intersection of chemistry, physics, and maybe like metallurgy is kind of the traditional way to look at materials engineering. I know our department kind of started as a metallurgy and mineralogy department. Um, yeah, there's a lot of emphasis put into understanding how the process structure and properties kind of all come together. And there's a lot of physics involved with that, chemistry involved with that, and then you kind of expand in your upper years, focusing on different applications of those, or where those applications would be. So it could be in forensic engineering, biomaterials, electrical materials. So it's very broad, but at its core, it's like the intersection of sort of physics and chemistry is how I would see it.
Wonderful. And that actually brings me to my next question in terms of, we get this question a lot from participants and from students. What's the difference exactly between chemical engineering and materials engineering? Because Joby, as you mentioned, it does have that intersection of physics and chemistry as well. But where would either of you see that difference and that separation between chemical engineering and materials engineering? Professor Ramsey, if you want to start first.
Sure. Yeah. I'm sure Joby could answer that really well. Yeah, it's a good question, and it's a question we get quite a bit, and it is a really good question. We've got a lot of faculty, in fact, or a number of faculty who are cross-appointed between ChemEng and MSc. We also have faculty who are cross-appointed with MEC and MSc and biomaterials and MSc. So, I mean, the world is increasingly interdisciplinary. I think that, like Joby's touched on, there's a lot of exciting sort of aspects of MSc that bridge the gap between different disciplines. So it's a great question, and it's certainly a reasonable question. What's the difference? I think if I had to kind of generalize, ChemEng is probably a little bit more kind of on the process, like slightly larger scale, whereas MSc is a little bit more focused on, like I said earlier, things kind of around the atomic scale, like what we call microstructure. But again, that's a generalization, right? So you can in MSc you can do things that are pretty close to ChemEng, pretty close to physics, right? There's people doing work with like LEDs and nanomaterials and things, which is very physicsy probably. And I don't know if that's a word, but yeah. Anyway, great question. I'd say we're kind of more on the atomic scale than ChemEng.
So it's not really that it's so much different, but it's really interconnected with a variety of different maths and different engineerings as well.
Yeah.
Joby, anything to add, Joby?
Yeah, there is a lot of overlap between the two. Actually, there's a lot of overlap with most disciplines. I would say actually we overlap more with mechanical engineering because we do share a lot of upper year courses. But the main difference between chemical and materials engineering, what Professor Ramsey just said, yeah, chemical engineering, the coursework does tend to veer towards scaling up processes, and you do work more with liquids. So I guess the main application you could think of is like oil and gas industry is what you'd be focusing on. Whereas again, materials engineering focuses more on solids. So a common example would be metals.
Yeah. Awesome. Thank you both. Now, Joby, this next question is kind of directed to you. And Professor Ramsey, feel free to jump in if you do have anything to add as well. Since you have finished your 4 years, it's a great knowledge base for our incoming students to hear from you as well. So what are some of the unique opportunities available to materials engineering students inside of the classroom or outside of the classroom as well?
I guess outside of the classroom, employers are very comfortable with letting materials engineer take on roles that would typically go to chemical and mechanical engineers because they know that with a materials engineering education, you could easily transition between both. Again, because there is such an overlap. In the classroom, I really liked a lot of our characterization labs. So we have this course called MSc 219, which I'm a TA for. So maybe I'm biased, but you get exposed to a lot of materials characterization tools that you necessarily won't be able to see until like a lot of graduate students don't use it until like they're later in their research. So things like an SEM, so that's a scanning electron microscope, XRD, X-ray diffraction, yeah, a lot of those tools that kind of allow you to analyze the material system at its atomic level. It's really great.
Yeah.
So yeah, and you get to do a lot of lab work in your first and second year, which is great, I think.
That real hands-on experience.
Mm-hmm.
Yeah. Scott, anything to add on your end?
Yeah, I mean, absolutely. I was going to talk about the same things Joey mentioned with the a lot of our lab facilities. There's fantastic microscopy facilities. Occam, it's like a $25 million facility. It's sort of one of a kind in certainly in Canada, and you know, top notch on the world scale. We've got this Walter Kurlock lab as well. One of our former faculty give a big donation for that as well. And yeah, so there's fantastic equipment that's available, and it is actually impressive how much the undergraduate students are supported in using that.
Awesome. And you kind of elaborated on my next question in terms of, you know, the labs and facilities, which is great to hear, right? You're not just learning in class. It's all about having those, you know, tutorials and lab experiences as well. Joby, do you mind mentioning or just talking a little bit about what it's like to be in that lab and really having your hands on those real world experiences as well?
Well, now it's a little different because most labs are just
Of
live
course.
demonstrations, but students have the opportunity to prepare their own sample and then actually learn how to use the certain whatever apparatus they're given. Yeah, and that allows them to kind of put something on their resume when they're applying to summer jobs or even their PEY co-ops, that they're familiar with these characterization tools, because a lot of companies also require these characterization tools, let's say in failure analysis or even in like chemical wet labs. Yeah, so it's, you are given, I mean, you are guided by the TA or whoever the lab supervisor is, but yeah, it's a lot of independent research that you get to do.
It's great. And kind of shifting gears a little bit towards the curriculum, do either of you mind just talking about some interesting components of the curriculum? Maybe your favorite course to teach, or maybe your favorite course to attend as well. Joby, if you'd like to start.
In the curriculum, well, there's a lot of emphasis first put in, I would say, physical chemistry and thermodynamics in your first and second year. So a lot of students don't like it, but it is very important and useful in the industry. But I really enjoyed like a lot of the technical electives. So I was able to take some biomaterial courses, which you kind of see the application, more application heavy, seen in hospitals and other research. Another course I took that I really liked was forensic engineering. So that's taught by Professor Perovic. So you kind of also go through real life case studies, learn about what a materials engineer does to support things like liability lawsuits, and how you would present information to kind of a wider audience with who wouldn't necessarily have a technical background. And yeah, there's also a lot of, like in your first and second years, it's a lot of like calculus, physics, and chemistry. So which is kind of the baseline for most engineering curriculums. But then when you get into your upper years, so third and fourth year, you really get to specialize in what you're interested in.
Professor Rhymes, anything to add about, you know, your favorite part of the curriculum or anything unique about the curriculum itself?
Yeah, I mean, why don't I talk a little bit about this third year course? Like Joby said, the first year is very close to being a common first year across all the disciplines. I've got this third year design course that I'm pretty excited about. Students do a design and they actually build something. And actually, I wanted to mention that because, you know, Joby had said, of course, in the remote environment, you're not really doing too much with your hands, but we've actually been working really hard on this kit that we're going to be shipping out to students in the next few weeks. So our third year students are all going to get this this box. Even we've coordinated. So I've got a grad student working on it. She's fantastic. Even students in China, we've shipped a box into China, and it's going to be shipped out from there. It was quite logistically challenging, but everyone's going to receive this kit with it's a little mechanical tester that has been designed by Crystal, my master student, and so the student has tools in there. Students are going to actually get to build that, and then they'll do some solid work, like some solid modeling of that, do some computer simulations, and then using samples that we're shipping out with them as well, they can actually do some validation, like actually do a mechanical test on this and see how it compares to what they did on the computer. So, we're really trying to still provide that hands-on experience as much as we can. So, I mean, it's unlikely by the time all of you reach third year, we'd still be in a lockdown. But, I'm a real big fan of hands-on work. I think it's really important. And so that's something I'm keen on continuing to develop into the curriculum.
That's awesome. Giving access to students no matter where they are. That's such a cool approach to things. It's great. We have a question coming in from one of the attendees. And the question is, what specializations in your upper years are available to materials engineering students? And kind of what type of employment opportunities are available to you, as you graduate, or maybe even specifically during the co-op program? Professor Renz, do you mind talking about any kind of the specializations available to students?
Yeah, I mean, I'm sure I can talk about the co-op one. But yeah, so we've got, I thought Joby might be in a good spot to talk about that question. There's a number of electives. You might actually, Joby, be more familiar with them. Sorry to dodge the question. I'm not sure, Joby, if you would feel comfortable answering that.
Sure. I'm not sure if it's the same now as it was when I was an undergrad, but you can specialize in biomaterials, nano, I think. I'm not sure if that still exists, and electronic materials, and also failure analysis and metallurgy. But there's also minors you could take, which is accessible to all the engineering disciplines, where you would take like a certain set of courses, usually in your upper years, that are technical electives specialized in one area. So you could take a bunch of courses that are specialized in, let's say, mineral processing, or you could take a bunch of courses related to biomedical engineering, failure analysis, et cetera, et cetera.
Yeah. To confirm, actually, for 2021, 2022, the areas of focus for materials engineering are biomaterials, design of materials, manufacturing with materials, and sustainable materials processing. So I guess they have, as you can see, every year and every few years, they do tweak them a little bit to really go in line with what's relevant nowadays as well, which is a great thing to have available to your studies as well.
So Nicola, that's printed in the calendar, I guess?
Yeah, in the view book, exactly.
The view book, oh, okay. I kind of hesitated on it because I think we've been discussing in the faculty about sort of changing that around. The courses that would have fed into that are still available, but I think we're moving kind of away from those specific sort of 4 areas. But yeah, that you can take elective courses definitely in biomaterials and forensic engineering, sustainability, nanomaterials, all that you mentioned. But I think we are kind of moving away from having those more sort of regimented specializations.
That's actually great to know as well. That's really cool. Thank you for letting us know. In terms of, I guess we have a question directed to really both of you. I think it's a really important question to ask. What kind of students would you recommend materials engineering to? The type of student who would fit a good description for materials engineering. Joby, if you can start since you lived through that experience, and of course, Scott, if you have anything to add, that would be great as well.
I wouldn't say that there's one typical student. Like if you had a group of friends and you identify, oh, that's the MSc person. Frankly, I just think someone who's curious. It does require a lot of intellectual rigor, so they're not easy courses, I'll tell you that. And I guess someone who works well in a team is very important. Well, I think that applies to all of engineering, but as you go in your upper years, there's a lot of group work where, since materials engineering is so interdisciplinary, you are working with chemical engineers, mechanical engineers, and even like software engineers in your project. So someone who's flexible enough to kind of switch their modes of thinking to kind of accommodate each background. So flexible, intellectual, and curious, to summarize.
It's great. Scott, anything to add on your end?
Yeah, so I would probably flip the question a little bit and say, what is the student interested in? And, if the student's interested in the stuff that we do, and, we're a small department, so there's a good interaction between students and faculty. But really, if you know, if you're excited about the material, then you can do well, right? And that's great. We want students who are passionate about the stuff that we do, and definitely if you find that, learning about things around the atomic scale and coming up with new materials, new processes, simulations, and all of these things that we're talking about is interesting to you, then it's the right place for you. And I think you gotta, and it's a very personal decision, right? Don't sort of base it on what you think the job market's going to be or anything like that, because that can change so much. But if you're doing something that you're excited about, you're going to do well, and that's going to open up all sorts of doors to you down the road, scholarships, job opportunities, and stuff like that. If you pick a program that you think might be the best one based on the job market or what someone else has told you, you're going to kind of struggle through it. You're not going to have such a good time. You probably won't do as well. So the right person, the right student to do MSc is a student who's passionate about MSc. Yeah.
That's a great way to wrap it up. That's a great way to put it as well. Now you mentioned, Scott, about looking forward to things post studies as well, in terms of employment opportunities, and if that's something you're passionate about as well. So I think it's really important to touch upon our PEY, also known as our professional experience year, or our co-op program. Now, Joby, you mentioned that you actually did your PEY as well, so you have experience with that. And Scott, you also have some kind of career opportunities that you can talk about too. So Joby, if you don't mind, can we start with you about what PEY meant to you, why you did it, and really what you did during that experience?
Great. So during my PUI, I worked at Inkbox Tattoos for 16 months. So if you're not familiar, it's a Toronto-based company that specializes in semi-permanent tattoos. That it's very atypical from your traditional temporary tattoos. So it was a great learning experience, because compared to other programs where your co-op lasts only 4 to 8 months, here I was responsible for essentially taking on the lead project lead into research and development, and then eventual scaling up of a totally new product. A side story, when I first joined on, there was like a patent infringement with their product. So then we essentially had to redesign the whole thing from the ground up. So it was a lot of responsibility, to be honest, but I feel like I've learned so much just as an intern. So being able to kind of learn a lot about cosmetic research and development, and then being able to learn about what a manufacturing process looks like and how you would scale that up, and even just like supplier chain relationships. So again, I wore many hats, but that my materials engineering background helped me, because I was able to think about like the product at the atomic level, at the formulation, and then being able to kind of extrapolate that information into what would make a successful manufacturing process.
That's awesome. That sounds so fast-paced and exciting. That's great to hear. And Scott, do you mind talking a little bit about potential professions, or really what you can do with that materials engineering experience?
Yeah, sure. So maybe I'll share my screen.
Yeah, please.
And so I can just show a few of the companies that our students have done PUIs, and many of them will go on and work their first job after graduation at some of these companies. So you can see some of the companies up here. There's obviously quite a range from semiconductors to sort of pharmaceuticals and aerospace and everything in between. A few more details. I won't go over sort of all the details, but you can certainly see there's a range of locations as well. Some domestic, some in Toronto, some international ones. We had a number of students go off to Belgium a few years back. Actually, just looking, yeah. So if we go back to this slide, right, you can see correction there. You can see the number of international positions. So there's a lot of variety available to you if that's something that you're interested in. Again, this is just a snapshot. There's certainly many others. This slide here is a slightly more broad net on some of the places, but again, it's not exhaustive. There's some of the places that people have worked. So consulting firms, more traditional steel processing, Dofasco there, energy. Number of students have gone into the nuclear industry, semiconductors here as well, imaging, food services, extractive metallurgy, you name it. So quite a range of different opportunities there.
It's great. It's so cool to see 21% international experience. I know a lot of the times our students say, so can I only work in Toronto? Is that the only opportunity available to me? And as you can see, being able to go to Belgium is a great opportunity for that international experience as well. Hopefully we'll be able to get back to that soon as well. Now we are running a little bit low on time, but I do want to ask really our last question I want to pose to both of you. Joby, it was directed to you, but I think Scott, it would be cool to hear from you as well. In terms of what was either your first mind-blowing experience when you said, whoa, I can't believe this is a part of MSc, or I can't believe this is something that I get to work with. Just something that really is made you passionate about studying materials engineering, or one of those aha moments throughout your experiences. Do either of you have one of those moments where a light bulb went off in your head and that passion really kicked in? Scott, if you can start. It looks like Joby's thinking a little bit.
Sure. Yeah, I mean, I think so. I did my undergrad at UBC out in Vancouver, and we had a common first year there, which personally I think it makes a lot of sense. And we're kind of moving slightly towards that here, where we got a common first semester and then a slightly specialized second semester, but we still really maintain the ability to transfer between disciplines at the end of first year. So make your best decision now, but at the end of the day, if you're going through first year and you realize there's a better fit somewhere else, you can do that, right? And that's the most important thing, that you take the program that you want. Anyway, thinking back to my first year, we had the series of professors come in from different disciplines, and I guess what resonated with me about MSc was just the understanding why, like I said at the start, why materials behave the way they do, and I love working on projects, making things. Maker stuff and home improvement stuff. And I've always had an interest in working with my hands. And so it was just fascinating for me to learn about, why, when I'm soldering some piece of brass, it gets softer, and you can't make it harder unless you remelt it and reprocess it completely and stuff. And I kind of knew some of these things just from having done it myself, but I didn't know why. And so it's just really exciting for me to learn the why for so many materials. And then like grad school, I went on, I did like biomaterials. I was working on a material to fix broken bones in the body. And, again, that's something I'm really excited about. And I think, anyway, a number of things, I guess.
It's awesome. And Joby, anything on your end? Those are great examples, Scott. That's great to hear. Really originating from when you were back in university, how that's influenced, again, where you are today. Joby, anything from you that really stuck out, or just something that you really love about materials engineering?
I guess it didn't really click for me until I started my PEY, but like a lot of the course content, I didn't realize how at the like a small change at the atomic level, or what perceived small change at the atomic level, can affect something so greatly. Like I think Professor Hibbard has a diagram where he shows like how a small change in a certain metallurgical microstructure at the atomic level kind of increases its strength by the tenfold, which is like, well, usually with like mechanical engineering, and chemical engineering, like very large changes only have like a margin. It's basically like a margin call at that point. So when I was working, like my supervisor at the time, she told me, it's like, wow, all those changes you're making like in the lab really make a really large difference once we get to the manufacturing process. Like, yeah, I guess that's what MSc is supposed to do. It's very small changes, but have a large impact on a product or a company.
That's great. Thank you both so much for that response. And again, it looks like we are out of time, so I just want to thank you for being with us today. Joby, thank you for taking the time out of your day. Scott, you as well. We really appreciate the inside knowledge, and it's clear just from the way the two of you speak how much experience you've had, and where that passion comes from. So we really appreciate it. I also want to thank Tyler, who is on the back end helping us answer these questions and giving us the participant questions for us to answer. Everyone, if you do have any additional questions for our team, please feel free to email us at engineering@utoronto.ca. Tyler just posted the link in the chat. Please feel free to follow up with us. As many questions as you can, please reach out. We're here to help you out. We're here to answer those questions. So please feel free to contact our team. And again, with that being said, we want to thank you all for joining us today. Stay safe, stay, if you're in Toronto, stay warm. And Scott and Joby, thank you again so much for the time you gave us today.
Yeah, you're very welcome. Thanks a lot.
Have a great day, everyone.
Bye.
You too. Bye-bye.
Bye-bye.